Hello, everyone. So our topic for today is trigonometric integral. So mainly we will be using trig identities in order to simplify the integral. So let's see. Let's take an example. Our first example is integral of cosine cube of x dx. So let's remind you of the most basic trig identity, which is sine square of x plus cosine square of x equal 1. So we will be utilizing this identity. So I can write this one as cosine square of x, cosine of x dx. Then I'll apply the identity to this term. It will become 1 minus sine square of x cosine of x dx. Then I have an integral of cosine of x minus sine square of x cosine of x dx. Well, we know that the integral of cosine is sine, but we also know that the derivative of sine is cosine, which is available in there. So the first term simply becomes sine of x, and the second term simply increment the power by 2 and divide by the new power, which becomes 1/3 sine to the 3x and add the constant. So that's the final answer. Okay. Let's take second example. It's an integral of the form sine of 5 sine to power 5x cosine square of x dx. So let's attempt to simplify this integral. So first of all, I will write this as sine to power 4x cosine square of x sine of x dx. So all I did, I split this one into two terms, sine to power 4 and sine of x. Now, I'll be using same identity as in example 1. Then it will become 1 minus cosine square of x. This is basically equal to sine square of x. But I have sine to power 4, then this one becomes square. And I have cosine square of x. And I have sine of x dx. Now I'll apply to the binomial definition to the first term. Then it will become 1 minus 2 cosine square of x plus cosine to the 4th x. And outside I have cosine square of x sine of x dx. Okay, now I would distribute the cosine square term. Then the integral becomes cosine square x minus 2 cosine to power 4 x plus cosine to power 6x, and still outside I have sine of x dx. Now it becomes straightforward. And here's why. Because we know that the derivative of cosine is simply negative sine. Let me write that down. D over dx cosine of x. That's simply equal to negative sine of x. So all I need is compensate for the negative sign when necessary and increment the power and divide by the new power. So I need negative here because I only have positive outside, which is positive sine of x. So this term becomes 1/3, negative 1/3 cosine to the 3x. The second term already has negative, so it will turn to positive. It will become 2 over 5 cosine to the 5x plus, oh, this one, no, it will becomes minus because it's already positive, minus 1 over 7 cosine to the 7th power plus constant. So that is the final answer. Okay. Let's solve more problems. Okay. So our third example is this. It's defined integral from 0 to pi of sine square of x dx. Well, for this problem, we need a slightly, we need different identity. So let's remind you which identity we need. So we know that sine square of x equal to 1/2 1 minus cosine of 2x. So we will be utilizing this identity. So our integral becomes 1/2 times integral 0 to pi of 1 minus cosine of 2x dx. And now should be just straightforward. So it's 1/2 x minus integral of cosine is simply sine, and I need to compensate for the angle by dividing by 2, and this sine of 2x, and it's integral from 0 to pi. So let's see, 1/2 pi minus 1/2 sine of 2 pi, and substituting 0 into x give you 0. Sine of 0 is 0, and sine of 2 pi is also 0. So I get my final answer to be pi over 2. Okay. Let's solve another example. Our fourth example is an integral of power 4, so sine to power 4x dx. Well, let's see. So Let me remind you of the identity again. So sine square of x equal 1/2 1 minus cosine of 2x. So this become, let me use different color as usually. It becomes integral of sine square of x and square dx. Then this one becomes one integral of 1/2 1 minus cosine of 2x. The whole thing is squared dx. I simply utilize this identity. And then becomes 1/4 integral 1 minus 2 cosine of 2x plus cosine square of 2x dx. I will need to apply the identity again. This term, it will become 1/2. Well, okay. Let me stop here and remind you of an equivalent identity for cosine. So cosine square of x equal 1/2 1 plus cosine of 2x. So that's the only difference in sign. For sine is negative, for cosine is positive. And so this term cosine square of 2x becomes 1/2 times 1 plus cosine double of the angle. So it becomes cosine of 4x dx integral 1 minus 2 cosine 2x plus 1/2 plus 1/2 cosine of 4x dx. Let's go step by step. 1 plus 1/2 is 3/2. So all I did, I combined these two terms. Minus 2 cosine of 2x plus 1/2 cosine of 4x dx. So it's 1/4. 3/2x simply. Minus 2 cosine 2x. So I already have a derivative of the angle, which is 2. So that simply becomes minus sine of 2x plus integral of 1/2 cosine 4x. The derivative of an angle is 4. So I need to divide by that. So this term becomes 1/8. Sine of 4x. And I simply will add the constant. So the final answer is 1/4 multiplied by 3/2x minus sine of 2x plus 1/8 sine of 4x plus constant. Okay. Let's solve a more examples. So I guess so far we have covered sine and cosine fairly. This a new example, which is example 5. It involves tangent and secant. So it's an integral of tangent to power 6x secant to power 4x dx. So the trig identity that we will be using here is that secant square of x is simply equal to tangent square of x plus 1. So what I'm going to do is this. Let me also remind you of that a derivative of tangent of x is secant square of x. So let's keep these two formulas in mind. Then I have tangent 6x and secant square of x times secant square of x dx. So I'll break the secant to power 4. Then this becomes tangent 6x, secant square equal 1 plus tangent square of x. And the second term simply secant of x, secant square of x dx. So all I need is to distribute 6 tangent to power 6x plus tangent to power 8x secant square of x dx. So a derivative of tangent secant square, derivative of tangent secant square, all I need is to increment the power and divide by the new power. So become tangent to power 7x and divide by 1/7. And the second term becomes tangent to power 9x divided by 9. And then simply add the constant. Okay. Yeah, let's move to a next example. Okay, for some reason this is not allowing me to insert a new page. Okay. Well, I guess let's just go to the first page and just erase those examples. We'll keep identity in there. Let's make some more space. Okay. Our next example is and this is example 6. It's an integral of tangent to power 5 theta secant to power 7 theta and then d theta. So for this one, what I'm gonna do is split both terms. So it will become tangent to power 4 theta and secant to power 6 theta, and I will have tangent of theta, secant of theta, d theta. So I will use those as a it's as a derivative that is available, so that I can integrate other terms. And one more thing, let's remind you again of the trig identity, is that secant square of theta is tangent square of theta plus 1. And also d over d theta of secant of theta is secant of theta, tangent of theta. So we need these. So what I'm gonna do is that I'll split tangent to the fourth as secant square of theta minus 1. This is equal to tangent square. And put square of that because I have on top tangent to the fourth. And here I have 6 square of theta. And then tangent of theta, secant of theta, d theta. Then this one becomes secant to power 4 theta minus 2, secant square of theta plus 1 multiplied by secant to the 6th theta, and then tangent of theta, secant of theta, d theta. Then I will get secant to power 10th theta minus 2, secant to power 8th theta plus secant to power 6th theta. All I'm doing is I'm distributing this term. And then I have tangent of theta, secant of theta, d theta. So the idea here is that my integral will becomes all secant of theta, regardless of what power it is, because I know from this formula is that the derivative of secant is secant theta tangent theta. So all I need to do again is increment the power and divide by the new power. Then the first term becomes 1 over 11th secant to power 11th minus 2 over 9th secant to power 9th theta plus 1 over 7 secant to power 7 theta plus the constant. So that's what it is as a final answer. Maybe before moving to next example, I would like to derive two formulas that it will be very, very useful. So see. Let's use different color. If I'm given an integral of tangent of x dx, how I would solve this? Well, we know that tangent of x is simply equal to sine of x divided by cosine of x. So let's see. Then I can write this as sine of x cosine of x dx. Okay, well, I know that d over dx, natural log of x, is simply 1 over x and multiplied by dx. So if I think about this one, if I think about my problem, so I have cosine at the bottom, and derivative of cosine is negative sign. So all I'm missing is the minus sign. So this one becomes negative natural log of cosine of x. But we know from properties of natural log, if I have -1 here, then this will become a exponent to the argument. Then it will become natural log of 1 over absolute of cosine of x. But 1 over cosine of x is simply secant. So that's the answer, and I'll add constant. The reason I put absolute value for the argument of natural log, because we know that natural log cannot accept a negative value as an argument. It's just that the function is not defined there. Okay, let's derive our next formula. If I have an integral of the form secant of x dx, I'm gonna solve this. So what I can do is that I can multiply the top and bottom by the same value. So I can do secant of x plus tangent of x, and on top also secant of x plus tangent of x dx. So the top becomes secant square of x plus secant of x tangent of x, and at the bottom I have secant of x plus tangent of x dx. Well, we know that, let me use different color, d over dx of tangent of x equal secant square of x, and derivative of secant of x equal secant of x tangent of x. So as we can see, the derivative of the bottom is available on top. Then that simply becomes natural log of secant of x plus tangent of x, and again argument of need to be placed inside an absolute value plus constant c. So that's what I have. Okay, let's move to the next page. I would erase in here. What have happened in here? Let's erase this. Okay. Uh, let's write the two formulas that we just drove on side so that we can use them and we have them as handy. This is derivative of tangent becomes natural log of secant of x plus c, and integral of secant of x dx, that is natural log, I keep forgetting dx. Oh no, I have it. Natural log of secant of x plus tangent of x plus c. Okay, let's see. If I have an integral of the form tangent to the 3x dx. Okay, how am I gonna go about this? Well, simply, let's break this one into tangent square of x, tangent of x dx, and then it becomes secant square of x minus 1 multiplied by tangent of x dx. Then distribute that, secant of x, tangent of x minus tangent of x dx. We know that derivative of tangent is secant square, so I'm gonna write this one by interchanging those two terms. Then derivative of tangent secant square, then simply this first term becomes tangent square of x and divide by 1/2. And integral of tangent of x, I'll use the formula in here. So it becomes natural log of secant of x plus c. Okay, because this wasn't bad. Okay, let's solve our last example for today. If I have an integral of form secant to power 3x dx. Okay, this one is a slightly different, and we are referring back to our technique from previous session, and we will be using integration by parts. And here's how we're gonna break it. So I will put secant of x and secant square of x dx. Well, we know the derivative of secant of x, and we know the integral of secant square of x. So the way we're gonna go about this is that I will set my u to be secant of x, then the u is secant of x tangent of x, and dv equal secant square of x dx, then v equal tangent of x. So put things together. So uv secant of x tangent of x minus integral of v and du secant of x tangent of x dx. So I will get secant of x tangent of x minus integral, I have tangent square of x secant of x dx. So the first term is already done, minus tangent square of x. We know that it is secant square of x minus 1. And I have secant of x here, dx. Then I have secant of x tangent of x minus, if I multiply, distribute the term, so it will become integral to the power 3x. And minus with minus becomes a plus, secant of x dx. But this is already similar to the term that we started with. So my original problem is already secant to the 3x dx, which is so far secant of x, tangent of x. All I'm doing is that writing the term in purple that I just found, minus integral secant to the 3x dx plus an integral secant of x dx. So I'll move this guy to the other side, so it will become 2 integral secant to the 3x dx, and that's equal secant of x tangent of x plus integral of secant of x is simply natural log secant of x plus tangent of x, which is just the formula that we drove now. And one last step is that I need to scale by the appropriate scalar. So I would need to divide both sides by 2. So our final answer would become secant to the 3x dx is 1/2 secant of x tangent of x plus natural log of absolute value of secant of x plus tangent of x plus the constant c. Okay, I think that is all I have for today.